Hello everyone, welcome to Data Discovery. At this video, we are going to see the concept related to skewness. Like previously, we have gone through the lots of the distribution, like normal distribution, okay, in which we have seen the probability distribution (PD), in which we have seen the PDF probability distribution function, PMF CDF, cumulative distribution function, lots of the distribution we have gone through the video, we have gone through the channel. I hope you have gone through it. In my description box, you will be getting all the links. Okay, but in this video, we are going to see the concept related to skewness. So, skewness it's comparatively most important if I need to say than the other distribution because like whatever the data that we are going through our real-time projects, that it will be not like a normal distribution. Normal distribution is nothing but the symmetrical distribution. Not every distribution will be symmetric. Some 0.1 0.001% you can see it in the format of symmetric distribution. That is something but a normal distribution in which the mean median value will be same. Okay, a major number of the part you will be getting the positive skewed or negatively skewed. This type of the distribution is definitely will be there. Okay, the percentage of this type of the distribution is comparatively more than the normal distribution. So if you are getting the positive skewed or negatively skewed or any type of the skewed data, then how we need to handle with it. Okay, so at that moment we can handle with the skewed data and we can proceed with it, or else if we need to change to the normal distribution, it's data by data it differs. Okay, so how actually we need to deal with it and what the properties related to this skewness that we are going to discuss at this video. Okay, so let's get started. So first, what is a skewness? Skewness it's nothing but a normal distribution. A normal distribution is nothing but the middle figure that I'm having. It's a bell-shaped curve. Okay, we can call the normal distribution as a bell-shaped curve, symmetrical distribution, normal distribution. It's up to us. Okay, there are various kind of the books. It refers to different types of the words. Okay, with a specific mathematical formula that describes how the data is spread out, right? Skewness indicates that the data is not symmetrical. It's not symmetrical. In which symmetrical you can say directly, like if I will be, if this is my distribution and if I will be cut it in between, then this will be around 50 percentage of the data and this will be around 50 percentage of the data. The distribution will be almost, it will be symmetrical, then it will be same, right? But in this skewness, if I will be cut it in between, then definitely that will be not same. This or this data, it will be not symmetrical, which means that it's not a normal distribution. Skewness is a measure of asymmetry of a probability distribution. So in the y-axis, you will be getting all the PD value, all the probability values. The greater the skew, the greater that distance between the mean, median, and mode. So here is the good relationship between the mean, median, mode that we will be discussing at this concept itself. So it's like that the greater the skew, okay, if the skewness is greater, then the distance between the mean, median, and mode will be affected. How it is skewed, okay? Like previously, we have seen the normal distribution, right? So we have seen some of the standard deviation part, how much standard deviation is away from the mean, one standard deviation, two standard deviation. If it is greater than three standard deviation, then we used to say this is an outlier part, right? So we have gone through some of the concept. Okay, over here also we can see there are very less number of we can say there are very less number of probability values. It's lying over here, right? It's lying over here also. Less number of probability. Here the probability in the y-axis you will be getting like 0.1, 0.2 percentage. Okay, it's nothing but 10 percentage, 20 percentage, 30 percentage, like that. So very less number of the people will be lying over here, if I'm giving an example. So it is considered as an outlier. So because of the outlier, it's got affected. So if due to outlier, if it's got affected, then even the properties of the central tendency, that is nothing but mean, median, mode over here, whatever it's written, even that will be also affected. Having a distribution like 1 2 3 till and the fourth value is 100. So if I'm having only 1 2 3 values, so if I will be finding the mean, then it will be around 6 by 3, right? Value, so you will be getting the mean around 2. But if I will be adding this value, this is nothing but an outlier. You can directly say this is an outlier value. So its lying range is 1 to 3, and over here one of the values is above the range. So if you will add it, then it will be comparatively more. Let's add it also. So it's 6 plus 100 is nothing but 106. Okay, if I will be dividing it, you will be getting a 35.3, something like that. Okay, so 35.3, it's previously we have add, we got around 2, right? So 2 and 35.3, you can see the difference. So because of one value, the distribution got affected. This what happens, like in the outlier that I have said, because of one value, this it's got affected. So because of that, the central tendency, the mean median mode will be also got affected. Okay, so if it affects, then what all cause you will be getting, right? So let's discuss about it. So that is one good relationship between the mean median mode related to positive skewed and the negative skewed. So let's discuss about it. Okay, right. So over here, this is a positively skewed. In the positively skewed data from the right hand side, you can see it's a elongated part, right? So same thing happens with the negative skewed. In the left hand side, you will be getting a slight elongated parts. So there are different types of the skew. In positive skew notes also, some will be very sharp data, some will be slight elongated. Okay, there are different types of the distribution also in positive also. So there are some properties, let's discuss it. So first property related to positive skew that will be seen. So over here the mean values, right? Median, mode. So in positively skewed data, the mean value will be comparatively high than median, and median will be comparatively high than mode. So you can say that mean value is comparatively higher than mode or comparatively higher than median. In the positively skewed, I can give a very good example. Like for example, if you will be taking the people who is writing a comments. Okay, there are very less number of the people who writes the long comments. If you can see the YouTube channels, any LinkedIn profile, there are very less number of the people who write a very long 10 to 15 lines of the comments. Very less number of the people writes just one or two line. So this is not the median number of people. Like we used to write around 1 to 2 lines of the comments, right? So this is one of the example. The other example, we can say the salary of our country. So there are very less number of the people who's having the highest number of the salaries. So major number of the people, the middle class families, lies just over here. So that's why. So these are certain type of the examples related to positively skewed. So there are various kind of the data. So by that you will be getting the positive skewed and negative type of the data. So in the symmetric, that is nothing but in the normal distribution, that is nothing but ND, we can see that the mean value and median value is equal to mode. So it's nothing but mean is equal to median is equal to mode. So all the values will be same. You can take it as vice versa also. If the mean median mode is same, then we can say it's a normal distribution. If mean is greater than median and median is greater than mode, then we can say it's positively skewed. So vice versa part also is just accepted. And in negatively skewed, that is nothing but NS. The first property is the mean is comparatively less than median, and the median is comparatively less than mode. It's nothing but the mode value is comparatively higher than median and it's comparatively higher than. So this is nothing but the first property is related to, this is first major property. And you can see this properties comes again and again in your projects. So as we have learned related to properties related to skewness, now before starting with the other properties, we just move to the formula. What is the formula related to the skewness and some of the concept related to it, and then after we will be moving to the properties and we'll just explain the properties one by one. Okay, so in the skewness, we have the, for calculating the skewness, whether it's a skewed data or not, that for concluding whether our data is consumed in a skewness formula or not. So for that we have the formula called n by n minus 1, n minus 2,
summation of x minus x bar divided by s the cube. This is the skewness formula, whether the data is skewed or not to find it. We will be calculating it. But nowadays, we won't calculate it manually for each and every particular features if we have data. So if this feature containing skewness or not, whether it's a positive skew or negative, we are not finding it by the formula. So directly we are using the pandas library. By using that, we can easily find whether it contains the skewness by import statistics this library. So it itself finds whether it's a skew data or not, or if it is positive skew, then positively skew data. So each and everything it itself finds. So nowadays, by using the library itself, we can do it. But actually we need to know that what's the formula it's following. So if it is positively skewed or negatively skewed, so by the values we'll just understand how actually it looks like. So over here -1 and over here +1. Okay, it's just a scale format. Okay, if it follows 0, then we say that it follows the symmetric method. Symmetric is nothing but ND, normal distribution. If it is lies between -0 0.5 or +0 0.5, it's nothing but the skewness, the score value. Okay, so if it lies between minus zero point 0.5 to plus zero point 0.5, then we say that almost symmetric. Not exactly symmetric, but almost it follows the symmetric method. Okay. And then if it follows from -1 to +1 from this method, then we say that it's moderately symmetric. So by using the pandas library itself, you can find the skewness of the particular data that you have, and you can check the score. What's the value of the score? Whether it's lying between minus zero point 0.5 or plus zero point 0.5, 0, -1. You can directly find the score, and based on that, you can easily assume that what type of the skew data that you are having, right? So if it less than -1, like -2, -3, or minus n values if you will have, or plus 1, it's nothing but 2, 3, 4, then it is highly skewed data. Over here we have the highly skewed data, right? So by the score that you are getting, you can easily assume that whether our data that we have, it's highly skewed or moderately skewed or symmetric, that we can find it by the score. There are four statistical moments. So there is not only four statistical moments, there are very many moments related to it, but still this four is the most important statistical moment that we are going to learn it over here. It's nothing but first one is first moments. It's nothing but mean. Second moment, it's nothing but variance. Third moment, it's nothing but skew. Fourth moment, it's nothing but kurtosis. Okay, I'll just represent over here. So each and every data uh, representing us in some or different way. Like one data is been by the distribution that we have learned, whether it's following a normal distribution, skew data, or kurtosis data. We can easily assume it by the distribution that we are having. We can find the mean by the statistical concept, or the mean, variance, standard deviation, that we can find it through here. Okay. So each and every value say something other the representing the data. Like if the variance is more, then we can easily understand if its standard deviation is more or variance is more. If what is the standard deviation? Standard deviation is nothing but how much far is away from the mean. So how much it's away from the mean, that we can find it. So by the score that we are getting, we can easily assume, we can easily predict that it's away from the mean. It's means it's not a symmetric something other we used to get it. Like we used to convert the normal distribution and the standard normal distribution, in which our mu is equal to 0 and sigma is equal to 1. So based on that we will be getting a plot related to it. Okay, and then after we can find the area of the particular distribution, like if from this to this that I'm getting. So by the probability distribution, we can easily find it, right? So each and every distribution says some or the other story related to data, right? Exactly. So same thing in our moments also. So first moments that we are the first statistical moments is nothing but calculate the mean of it, of the data, particular data that you're having. Second is variance, that we have already learned in our series. I hope you have watched my variance and standard deviation. Now the third moments that we are learning it over here, it's nothing but a skewness. And four moments, the upcoming videos, the next video is nothing but that I will be doing related to kurtosis. So there are many such statistical concept, but still this four is the most important. The four is the most important part, as we have gone through some of the properties and formulas, and then moments, what is statistical moments, and then the diagrammatically, whether it is symmetric or almost symmetric or moderately symmetric, or it's completely skewed data related to diagrammatically, we have represented it. Now let's move to the properties, some of the properties, the most important. Okay, so the second property, the first property we have already discussed, that mean is greater than median is greater than more, something like that. So now the second property that we have represented over here is nothing but the normal distribution has a skewness of 0, right? So if it is a normally distributed data, then your skewness will be 0. Skewness will be 0. Like previously I have given one concept related to this one. Like I have represented 0 minus zero point 0.5 plus zero point 0.5, then minus 1 1. So if it is 0, then it is normally distributed. Like same thing happens, then if it is a normal distribution, then the skewness will be definitely 0. So by the property itself you have got it. So now the next property is nothing but skewness of the data set indicates whether deviation, standard deviation from the mean are going to the positive or negative, right? The skewness from whether it's a positively skewed or negatively skewed, the data that you are having indicates whether deviation from the mean, if you are having something mean over here, are going to the positive side or negative side, that you can understand it, right? If you're having a mean something over here, whether it's a positive or negative values that we are getting, so by the skewness of the distribution that you can get it over here. By normal distribution we can find z score, but the skew data we if we find to if we need to find the area, then that couldn't able to do. Why they are saying like that? Like previous video, I hope you have gone through it, but still I'll just revise it. If you have a normal distribution data, okay, x, you take any values, any percentage or something, any values. In y you are having all the probability distribution. It's nothing but all the probability values that you are having, point 0.1, point 0.2. So whatever the probability values that you're getting over here, if you need to find this area, you can easily find it. It's nothing but integration from 0 to that lower limit and higher limit. If I'm having a lower limit as 0 and 1, okay, and f of x dx. So if I will be finding it over here, then I can get the area of the particular term. But this area can be found if the distribution is normal distribution. But if not, it's normal distribution, then you couldn't able to find the area by using the z score method, or by using an integration you couldn't able to find it. So like previously also we have seen some of the z score term, like this to this, what's an area related to it. So what we have done, we have taken this whole value as 1 minus by using a z score term. So if it's percentage like something around 89, so based on that we calculated this term, right? We can calculate this area. By using a z score method we can find the area of the normal distribution, but for the skew data, because z score is not valued in the skewness of the data. So if it's following a normal distribution, then only we can find the
z score, the area of the particular it. Okay, so by Box-Cox transform, we can remove skewness. There are some mathematical concept in which we can remove the skewness. Yeah. So now let's start with the code of these skewness. This all the code that whatever that I will be doing in my channel, you will be getting in my GitHub link. That all the GitHub process that I will be sharing in the description box. You can just move to it and you can just get my all my code. Okay, for the statistics purpose, I have prepared one a separate repository so that you can get all the code on that particular statistic repository itself. So, what is this skewness? Skewness is nothing but is a measure of the asymmetry of the probability distribution of a real valued random variable about its mean. Exactly, that we have gone through it. Okay, it's just nothing but the asymmetry of the probability distribution. And what this skewness measures, the skewness measures the degree of the symmetry of the probability distribution. Yes, the normal distribution is symmetric and has a skewness of zero. Yeah, if the distribution of the data set instead has a skewness less than zero or negatively skewed, that is nothing but a left skewness, and that then the left tail of the distribution is longer than the right tail. Right, if it is leftly skewed, that is nothing but negatively skewed data, then the left tail of the distribution is longer than the right tail. Tail is nothing but the end of the particular distribution that you are having. Right, and the positive skewness is nothing but right skewness implies that the right tail of the distribution is longer than the left tail. So we used to say that it's the right tail, left tail, this tail of the data. Okay, so in my code that I have prepared my own data, like I have prepared my array. So I know that some of the values, so based on that normal distribution only I have done it, but it's currently slightly skewed. So as I have said, by the skewness, by the statistics library itself, from the scipy or stats import skew, it directly finds the skew. That formula that I have shown it in my lecture, that whatever the formula for skewness, the score that you will be getting, so it directly represented in this library itself. Okay, so no need to worry. So I have plot two data, one of the histogram and another one for skewness, so that you can easily identify that how the histogram looks like. So it's not, it's slightly rightly skewed by the histogram itself only. You will be getting like one of the data point in this range, it's missing. So because of that, it's slightly rightly skewed, that you can get it over here. Right, and then after, you can see the value of the skewness is minus 0.32. Like I hope you remember, if it lies between minus zero point 0.5 to plus zero point 0.5, then it's almost symmetric. Right, so even it looks like almost symmetric, slightly rightly skewed and almost symmetric. So this is how we have done with the part. So if I will change the data as per the need, then it will be quite skewed. It will be like quite a normal distribution data. So I hope you got the skewness part. In my upcoming videos that I will be discussing about the kurtosis QQ plot in on my upcoming videos. If this video is find so useful, do like, share and subscribe to the data discovery. I will be coming across more related to data science stream, all the data analysis part, MLDL, NLP, all the projects related to it. So do like, share, and subscribe to Data Discovery. Thank you.